right. So in section 2, quadratic equations, what is the standard form of a quadratic equation? Standard form of an equation, not a function. AX, yes. Yes. Equals 0, yes. Yeah, what does this mean? It tells us anytime we want to solve for a quadratic equation, we have to set it equal to 0. Because this is our y value. So when you set y equal to 0, what are you looking for? When you set y equal to 0 and solve for x, what are you finding? The x-intercepts. These are what you call the solutions. When you solve a quadratic equation, what you're finding are the x-intercepts of the graph. Section 3 deals with the analysis of the graphs of quadratic equations. In other words, we can find the rough sketch of what the graph looks like without actually doing much work. We have two forms or two ways of determining all this stuff. The vertex form and the quadratic equation form. What's the difference? The quadratic form, the equation looks like this. F of x equals a, open parenthesis, x minus h squared plus k. Where a, h, and k are numbers, integers. The quadratic equation form is set equals 0. Or we can even have the quadratic function, f of x equals. Both ways work. Both ways will give us the final answers, but which one's easier? It all depends on your preference. We learned how to factor equations last time. Oh, and use the complete the square and the quadratic formula. So the vertex form, how do we get it into the vertex form? Okay, let's say we start off with this method, the standard form. Set it equal to 0 because we have to first solve it. We're going to use the complete the square method. So let's follow. Remember the procedures for complete the square? Your leading term has to be 1. If it's not, divide everybody by it. What's the next thing we move? Move the 8, because you have x's on one side, non-x's on the other. So I'm going to show you two ways of doing this. One, this way, which is the easiest way. The other way is you keep everything to one side, which could get confusing. Okay, so we move the constant term over. Then what do we add to both sides? B over 2 squared. What's B? Whatever's in front of the x. So we have 6 over 2 squared. Add that to both sides. 6 over 2 squared. And don't worry about the sign, because when you square it, it becomes positive. So just put the number in front of it, whatever number is in front of x. On the left-hand side, only do what's inside the parenthesis. Don't square it. So 6 divided by 2 is 3. On the right-hand side, work it all the way out. So we have -8. 6 divided by 2 is 3. 3 squared is 9. So 9 minus 8 is 1. On the right-hand side, work it all the way out. Left side, only do inside the parentheses. Remember this part so far? Now, complete the square. On the left-hand side, we're going to put it under the square. So anything under the squares and the first sign go inside here. So x, the first sign's plus and 3. So far, so good? Now, if we were going to solve this, we'd square root both sides, but we're not trying to solve it. We want to put it into vertex form. Now, move the 1 back, move the constant back. So we have x plus 3 squared minus 1. And there we have it in vertex form. Now, why is this important to us? Because if we're in this form, the vertex is the h and k. Because this is the vertex form. Remember, inside the parentheses, always opposite the sign. Outside, it's always what it is. So the vertex here is what? Opposite sign. Negative, and then -3, -1. That's the vertex. Okay, so we found the vertex. Do we know the y-intercept from the original equation? The y-intercept is 8, right? Let's see. Notice 8. Let's see. How would we find the y-intercept here? You would think, but remember in chapter 1, how do we find the y-intercept? First step, set x equal to 0 and solve for y. So if we set x equal to 0, What do we have inside the parentheses? Just 3. 3 squared is what? -1. There it is. There's a y-intercept. So if I give you the vertex form, or if you get the vertex form, just set x equal to 0 and solve it. That's your y-intercept. So your y-intercept is at 0, 8. How would you find the x-intercepts? Yeah, is to find the x-intercept, you set y equal to 0. Yeah, because you have to move the 1 over. Then square root both sides, plus or minus. So plus or minus 1 equals x plus 3. Work it out. Subtract 3. So x equals -3 plus 1. X equals -3 minus 1. -2 and -4 are your x-intercepts. But we did that a while ago, when in the last section. So if you're given the vertex form, keep on working it out. Set it equal to 0 and solve for x. Square root both sides. Whenever you square root something squared, you have to put a plus or minus in front of the answer. Make sense? It's a lot of moving parts, but again, it's not that complex. So what all do we need to know in order to draw a graph? Let's first answer that question. We need to know the x-intercept, the y-intercept. No, because the slopes, because it's a parabola, the slope changes no matter where you are. It's a different slope everywhere around it. Yeah, so that doesn't work. We have to know the vertex. The domain of any parabola is all real numbers. Yes, so it's -infinity to +infinity. That's the domain. That's because there's no restriction on x. But the range, because it's the range. Okay, here's the cool thing. When we do the next part, well, actually, we can do it here. Once you find the vertex, it's an x and a y value pretty much. It's a point. Both of these have a meaning. The x value of the vertex is the axis of symmetry. What does that mean? Axis of symmetry. Yeah, it's the line that creates a mirror image on both sides. But it's the x value of the vertex. Because if you drew a line across the x point of the vertex, you'll have a mirror image on both sides. The y value is your minimum or maximum point. That's either the lowest or the highest point your graph will reach. What determines whether it's a maximum or minimum? if A is positive, well, I'll show you, we'll talk about what A is in a second. The graph opens up. If it opens up, then we have a minimum. That's the minimum is the lowest point. If A is negative, opens down, then we have a maximum. Because maximum means the highest, the largest. And I'll show you what these mean in a second. So a couple more things. We can find the maximum or minimum. The direction of the graph. We can find the interval where it's increasing and decreasing. And we can find the range of our data. And the funny thing is, it looks like a lot of work, but the only one that really requires a lot of work is the x-intercept. That's the only one that requires us to do work. So these are my two ways. This is the vertex form. This is the standard form. So if the coefficient in front of the parenthesis or the leading term, leading coefficient, if A is positive or A is negative, let's look at the graph. If A is positive, the graph looks like this. If A is negative, it looks like this. If A is positive, then we have a minimum point. If A is negative, we have a maximum point. And let's look at the range. The range is whatever your y value is, your on the vertex, the y value of vertex, because it starts at that point and it goes up forever. If A is negative, then that's our range. So in other words, If you have it in this form, in the vertex form, then y equals k. Whatever this value is the y value of your vertex. Because remember, the vertex is hk if it's in the vertex form. But if it's in the other form, if it's in the standard form, how do we find the vertex? It's an equation. The vertex is negative b over 2a. And whatever you get there, you plug it back into your function, and that gives you the y value of the vertex. Let's work this one out with the same equation we had a second ago. X squared plus 6x plus 8. Let's look at that one. Okay, so f of x equals x squared plus 6x plus 8. Let's look at the vertex. First off, we have to label A, B, and C. What's A? This A is the coefficient of x squared. It's the number in front of x squared. What's B? It's whatever's in front of the x, and then the constant is C. By looking at these, what can you tell me about the graph? Do we have a maximum or minimum? I don't know. Is A positive or negative? It's positive. So if it's positive, what does it look like? It opens up. So that means we have a minimum. So we know we're going to have a minimum. The formula is negative b over 2a. So the x value is negative b over 2a. What's b? 6. What's a? 1. So negative 6 over 2 is negative 3. So this is also our axis of symmetry. The y value of our vertex is whatever we got from the x, plug it back into our function. Negative 3 squared plus 6 times negative 3 plus 8. Negative 3 squared is 9. Positive negative is negative. 6 times 3 is 18. Plus 8. Nine plus 8 is 17. 17 minus 18 is Since 18 is bigger, it's negative, -1. So our vertex is at -3, -1. What's our range? Our range is y is greater than or equal to -1 or -1 to infinity. So far, so good. Now, with what we have here, tell me the intervals. Where the graph is increasing and where it's decreasing. Remember, our vertex was -3, -1. Tell me where it's increasing, where it's decreasing. What all do you need to know to tell me this? If we drew the graph, what all do you need to know? Well, the vertex is at -3, -1. Does it open up or down? It opens up. It opens up because A is positive. So that means we'll have at -3 is the lowest point, right? Well, it goes on to infinity. So where is it decreasing? Sure is. No, it's decreasing from everywhere from -infinity to -3. It's decreasing from -infinity to -3. That whole side of the graph is going down. Where is it increasing? From -3 to infinity, it's always going up. Because when you're looking for the interval where it's increasing and decreasing, you're looking for the range or the domain. You only deal with the x values. And notice there is no bracket. It's always parentheses. Why? At -3, what's it doing at -3? Is it increasing or decreasing? It's doing nothing. It's flat. It's a horizontal line. Well, yeah, so that's why we can't use it. It's decreasing all the way up to -3 and increasing from -3, not at -3. Let me put some other examples. Let's figure out all this stuff. So give me a rough sketch of this graph. George, you have to tell me all the stuff, where it's increasing, where it's decreasing, the vertex, the x-intercepts, the y-intercept, the axis of symmetry, the maximum minimum point. I'll list it all here for you. So tell me all this stuff. 1, 2, 3, 4, 5. All right, which two of these we can do just by looking at that equation? The y-intercept is where? So y equals at 0, 23, or y equals 23. That's the y-intercept. What else can we determine? Yeah, so in other words, it tells us if it's maximum or minimum. How do we know it's minimum? Right, because the coefficient of x squared is positive, so it opens up. So we have a minimum. Okay. Well, we can't figure out anything else yet. So what method are you going to do? You're going to convert this to a vertex form or use the formula for vertex? Which is what? What's the formula for vertex? Yeah, so the x value is negative b over 2a. And b is 10. So it's negative 10. Let's label these. A is 1, b is 10, c is 23. So negative 10 over 2 is negative 5. So where else did that answer go? Well, it goes in the axis of symmetry. X equals negative 5. It's the vertical line going through negative 5. That's the axis of symmetry. But yes, we put the negative 5 into the equation. Very good. So negative 5 squared is? Nope, positive, because negative. Positive times negative is negative. 10 times 5 is 50. Yeah, so it's 48 minus 50 is negative. Since 50 is bigger, it's negative. 50 minus 48, negative 2. So the vertex is at negative 5, negative 2. What else can we figure out from there? The range. What's the range? Infinity. Or y is greater than or equal to negative 2. You can say that. Why is it a bracket? Because you can include it. The range, you can start off at negative 2 because it's the lowest point, and then it goes up from there. The range are all the y values you'll end up with. So since that's our vertex, we have to be able to get to that point. What else can we do from this list once we find the vertex? Well, the intervals. We can't find it from the x. We cannot find the x-intercept there because that's a whole separate equation. But from the vertex, we can find the intervals. Because we only look at this. Since we know the graph opens up, it has to go down to negative 5 and then go up. from to -5. That's what goes down. Yeah, and then it goes up from -5 to infinity. One, two, three, four, five, six. The only thing left we have to do is the x-intercept. How would you find the x-intercept? We have 3 methods we can use to solve it. Which way always works? Quadratic formula, yes. Because we can't factor it. Why can we not factor it? Because what times what is 23? When you add them, you get 10. 23 is a prime number, 23 times 1. So we can't factor it. We could complete the square and solve it that way. Or it's much easier if you use the quadratic formula. So we know what A, B, and C are. A is 1, B is 10, C is 23. So what's the quadratic formula look like? What's the formula? That's the quadratic formula. Again, whenever you do these problems, write down the formula first to help you memorize it. Now you start plugging and playing. So negative B is 10. B is 10 squared. 4, A is 1, C is 23, and A is 1. So work inside the radical first. 10 squared is 10 times 10 is 100. Negative times positive is negative. 4 times 1 is 4. 4 times 23. 92. Got 23 times 4. 4 times 3 is 12. 8 plus 1 is 9. 2 times 1 is 2. Negative 10. 100 minus 92 is 8. Now, remember what we called this inside the b squared minus 4ac. What is that called? Starts with a D. The discriminant. What does the discriminant tell us? It tells us the number of answers we're going to have, how many intercepts we're going to have. If the discriminant is positive, we have 2 solutions, 2 x-intercepts. If it's equal to 0, we get 1 solution. If it's negative, we get no solutions. Now, since 8 is positive, that tells us what? We're going to have 2 solutions. We're going to have 2 solutions because of that plus or minus in front of it. So what do you do next? What do you do here at this stage? Can you do anything inside the radical? What? Oh yeah, we have square root of 8. What is 8 made up of? 2 times 4, 2 times. So 8 is 2 times 2 times 2. Once you have 2 of a kind, you can pull it out in front. So we have -10 plus or minus 2, and inside the radical we have a 2. Because when you have a square root, once you have 2 of a kind, that comes out. Square root of 4 is what? 2, so it comes out. Anything else stays inside. In your numerator, they both have a what in common? They both have a 2 in common. So if factor out a 2, I could factor out a 2 out of the top. So the 2's cancel. That leaves me, my answers are -5 plus radical 2, -5 minus radical 2. These are my 2 answers. Those are my x-intercepts. Again, so we learned how to do that last section using the quadratic formula, which always works. If worse comes to worse, use the quadratic formula to find the x-intercepts. The y-intercept is right there in the equation. What do y'all think? Good so far? Okay, I'll leave the rest, let y'all figure out how to do the rest of the stuff in homework. Because yeah, I could give you, we could do a bunch of more examples, but it'd be the same stuff. It's y-intercept, the x-intercept, we just solve it out and go from there. Now, the next section, section 4. Solving radical and rational equations. Solving radical and rational equations. What's the difference? The difference is pretty straightforward. Radical is a square root. Rational means we have fractions. Or a over, so we have some kind of fraction. Where x can now be on the bottom. So whenever you see rational, it means a fraction. We'll start off with rationals. Let's start with something easy first. The rules are always the same. If you have fractions and an equal sign. Get rid of the fractions. So if you have fractions and an equal sign, get rid of the fractions. How do we get rid of the fractions? First step, find the LCD. What is the LCD in our example here? 5 times what equals 1? The least common denominator is, what's the smallest number they all fit into? Not the least common multiple, the least common denominator. What's the smallest number that 3, 2, and 5 fit into? Well, multiply them. 3 times 5 is times 2. Worst case scenario, if you don't know, just multiply them all. Because if that's the case, then since you multiplied them, it has to be divisible by it. Then multiply the LCD to each term. Remember what a term was. A term is anything separated by a plus, minus, or an equals. So how many terms do we have here? 3. Here's the first term, the second term, the third term. This is an equation on top. You can't split those up. So we multiply 30 to each of these terms. Third step. Remember, our objective is to get rid of the fractions. Since we multiplied by the LCD, we know that they have something in common with the denominators. So cancel them. 3 goes into 30 how many times? 10. 5 goes into 30 6 times. 2 goes into 30 15. So we have 10 times x, 6 times 4, 15 times x plus 2. It's the same. The top and the bottom equations are the same. It's just that we got rid of the fractions. Multiply to remove parentheses. So 10 times x is 10x. 6 times 4 is 24. 15 times x is 15x. Plus 15 times 2 is 30. And then solve. It's always, whenever you have fractions and equal signs, it's always these 5 steps. So what do you move? Which one? No. What are you solving for? So the x's are your more important ones. Always keep the positive ones. Yeah. So you always move the smaller x to the larger. Move the x's first. So which one do you move? And how? How? Subtract 10x from both sides. 15 minus 10 is 5. Now, you have all the x's to one side. Whatever's not x goes to the other side. So get rid of the 30. $30 is bigger than 24. It's negative, so the answer is negative. 30 minus 24 is 6. Equals 5x. How do we get the x by itself? Divide by 5. So x is equal to negative 6 over 5, or negative 1 1/5. That's an improper fraction. And then get used to, if x is in the denominator, always check your answers. Because sometimes it'll make it unusable. I mean, you should always check your answers, but if you're going to be lazy about it, definitely do it if x is on the bottom. Let's try another one. X minus 8 over 3. X minus 3 over 2. Go. So the LCD is 6. So we multiply 6 to both of these equations. Not equations, but terms. And then 6 times 0. We multiply it. Now we reduce. 3 goes into 6 2 times. 2 goes into 6 3. So we have that plus 3x minus 3 equals 0. Multiply to reduce, remove parentheses. 2 times x. Positive, negative is negative. 2 times 8, 16. Positive. 3 times x minus 9. After you get rid of parentheses, always do what? Combine like terms. Very good. 2x plus 3x is 5x. They're both positive, so you add them together. Then we have negative 16, negative 9. They're both negative. 16 plus 9 is 25. Add 25 to both sides. And divide by 5. Now, you should have known you had it wrong if you would have checked your answers. So we have x minus 8 over 3, x minus 3 over 2 equals 0. This is CYA. So anywhere you see an x, you put a 5. 5 minus 8 over 3. 5 minus 3 over 2. 5 minus 8 is negative 3 over 3. 5 minus 3 is 2 over 2. Negative 1 plus 1 is 0. That's why it always helps. Always, always, always check your answers. You'll know what's going on if it's right or wrong. Okay. So much for Mickey Mouse questions. Let's put X on the bottom this time. X squared divided by X minus 3 equals 9 over X minus 3. Same process. Do we have fractions? Yes. Do we have equal signs? Yes. So what's my LCD? X minus 3. The X minus 3, it's an equation. The LCD can be an equation, it could be a number, it could be a letter. So in this case now, since my LCD is that equation, I multiply it to both sides. I found the LCD, which is X minus 3. I multiply it to both terms. Reduce. How many times is X minus 3 going to X minus 3? Once. X minus 3 goes to X minus 3 once. I multiply to get rid of the parentheses. And I solve. X squared equals 9. Square root both sides. So the X squared and the square cancel. So X equals what? And anytime you square root something squared, you have to put a plus or minus in front of the other side. So the answer is plus or minus 3. But we're not done yet. Check your answers. X equals 3. X equals negative 3. So I have X equals 3. Here's the original equation. So plug in on the left side, plug in 3 in place of X. Three squared is 3 minus 3. So what does that tell you? Are they equal? No. Can you divide by 0? No. So no solution. So it cannot be 3 because it makes the bottom equal 0. You cannot have 0 on the bottom. So let's try the other one. Negative 3 squared. Negative 3 minus 3. Negative 3 minus 3. I plug in negative. So negative 3 squared is 9. Negative 3 minus 3 is negative 6. They're both the same. So my only answer is x equals negative 3. That's my only answer. That's why you check your answers, because one of them or both of them may give you zeros on the bottom. Let's try some more. No, it's 3. Five over 3x plus 2 equals 3 over 2x. So now what's my LCD? My LCD is 3x plus 2 times 2x. So now I got to multiply the LCD to both terms. When you have fractions and either the top or the bottom or both, if they have an equation, put them in parentheses. If they have a plus or minus, put that, because it's in one equation, it has to stay together. So on the left side, what cancels? 3x minus 2, 3x minus 2. So we're left with 2x and 5. The 2x's cancel on the right-hand side. 3x plus 2 times 3. We just reduced. Multiply to get rid of the parentheses. 2 times 5 is 10x. 3 times 3 is 9x. Positive, positive is positive. 2 times 3 is 6. Now solve. We have x's on both sides. Move the smaller to the larger. Ten x minus 9x is x equals 6. What do you do with that answer? Yeah, check it. 3 times 6 plus 2. Does it equal 3? 2 times 6. Three times 6 is 18. 18 plus 2. 2 times 6. 12. Did you say 8? 2 times 6 is not 8. It's 12. All right, now what do? Simplify. 5 goes into 5 once. 5 goes into 20 4 times. 3 goes into 3 once. 3 goes into 12 4 times. So x equals 6 is my answer. So that's good. Okay, those are pretty. Now we're learning about this x's on the bottom stuff. I got to teach you one concept here. It's called the difference of two squares. I went over this once about 2 weeks ago, but here it is again. Difference of two squares. If you have a number or a series of numbers or variables and stuff that's perfect squares, and you subtract them, you can factor them in AB. So it's AB, AB, one's plus, one's minus. We talked about this when we did the conjugates, because it got the middle terms canceled the i's, and when you square an I, it becomes a -1. So that's what we did the conjugates. So if I had, is this the difference of two squares? What's 36 made up of? 6 times 6. So it's x squared minus 6 squared. So therefore, the factored form of this would be what? Yep. Yep. So that's the difference of two squares. So far, so good. So look at both numbers. Even if we had something like this, what is 9 made up of? 3 times 3. So this is the same thing as 3 squared x squared, right? Because 3 squared is 9. 16 is 4 times 4. Since they're both squared, I can separate them. Three x plus 4y, 3x minus 4y. So it can happen like that too. So it doesn't matter. So look at, if you have a minus, you have two terms and you have a minus between there, see if both terms are perfect squares. If they are, then you can factor them out. Okay. Two over 3x plus 6 plus 1 over x squared minus 4 equals 4 over x minus 2. That's supposed to be deleted. That's 2 over 3x plus 6 plus 1 over x squared minus 4 equals 4 over x minus 2. Okay, the first thing you have to do is factor out the bottom. So, can this be factored any further? 3x plus 6. Do they have anything in common? A 3. So we can take out a 3, we're left with x plus 2. Yeah, 1x plus 2. How about the x squared minus 4? Can that be broken down any? What's 4 made up of? So this is the same thing as x squared minus 2 squared. The difference of two squares. Didn't we just talk about that? So it's x plus 2, x minus 2. And it's x minus 2. So take your denominators and factor them. So this is what we have right now. It makes it easier. It makes it, when numbers are smaller, it's much easier to see stuff. That's why we factor out the bottom whenever we have those. Also factor out the top, just in case anything cancels out. If anything cancels out up and down, you can get rid of them. That's why you factor them out. So what's my LCD? So it's it's 3, x plus 2, and x minus 2. That's all we have on the bottom. So that's my LCD. Because these two have an x plus 2, these two have an x minus 2. So what do I do with the LCD? I multiply it to each term. That's the first one. This is the second one. And that's the third one. So all we do is just put our LCD in front of each of those terms. I mean, anything difficult so far? We factor out the denominators. That didn't take much time. It takes more time writing it than it's really difficult. Now what do? Yeah, simplify. What cancels on this one? The 3 cancels. X plus 2 cancels. What do we have left? We have x minus 2 times 2. X plus 2, x minus 2 cancels. So we have 3 times 1. And then x minus 2 here cancels. 3 x plus 2 times 4. It looks a lot easier now. It looks tremendously easier. Our next step is what? Multiply to get rid of the parentheses. 2 times x is 2x. Positive times negative is negative. 2 times 2 is 4. Positive times positive is positive. 3 times 1 is 3. 3 times 4 is 12. 12 times x is 12x. Positive, positive is positive. 12 times 2 is 24. Combine like terms. 2x, well, negative 4 plus 3. 4 is bigger, the answer is negative. Minus 1. No. Since you have x on both sides, always move the smaller x to the larger x. So we subtract 2x on both sides. You never want to have a negative coefficient when you move things around. If you do, move the other one. 2's cancel, so I have -1. 12 minus 2 is 10x. Subtract 24 from both sides. What's that? Well, no, because we're x is the important one. Once the x is by itself, then we move everything else over. So they're both negative, so it's 25, -25. Divide by 10. So only one negative, so the answer is negative. They both have a 5 in common. 5 goes into 25 5 times. 5 goes into 10 twice. Two goes into 5 twice with 1 left over. So all depends on how it wants it. So both of those are the answer. Okay, but remember, when we check them, when you check them, what you're really looking for will this answer make any of the denominators 0? Remember, our original equation was 3x plus 6, 1x squared minus 4, x minus 2. So whenever you have equations like this, what you can try to do here first is take each of these denominators, set them equal to 0. So if we set this first one equal to 0, what do we get? Subtract 6 from both sides. Divide by 3, you get -2. So in this one, if you cannot use a -2, because if you use a -2, what happens to the bottom? It becomes 0. This one, x squared minus 4 equals 0. X squared equals 4, square root both sides, x equals plus or minus 2. So I cannot use a positive or a -2 because it's going to make the bottom 0. And this one. So I cannot use 2 or -2 in my answers. That's the only restrictions I have. So in other words, remember when I told you always check your answers? That's why I'm asking you checking it to see if the bottom equals 0. So another way you could do it is just take each bottom, the original equation, set them equal to 0 and solve for them. We know if either of our answers are 2 or -2, we can't use them. Anything else works. Anything else works. But since our answer is -2.5, it works. The only thing we can't use are 2 and -2. Let me see which one I want to use now. This one. So tell me what x's I cannot use. X, it's not an equation. What x's can I not use? Give me an x. Give me a number I can't use. We just talked about it 5 seconds ago.
0.
What equation did you use to get 0?
We said we do like that. can't even, equal to the. Yeah.
So what x's can I not use? You have to do some math. I mean, I see people writing it down. You guys are just guessing right now. Why? Right, you cannot use one. What about another one I can't use? Can't use a negative one because this one will make this one 0. What's this one going to tell you? Plus or minus 1. So these are the only two numbers I cannot use. Right, because this tells me my restriction of x. Once I finish solving it, if it's either one of these, I can't use it. Remember back, let me see, where is that one? In this one, what x can I not use?
Positive, negative.
No, x minus 3, x minus 3. I can't use x equals 3. Well, one of my answers was x equals 3, so I can't use it. What's the first step? Okay, that's the first step. Find your x's you can't use. Second step, factor of the denominators. This one's done. This one's done. What does this one factor out into? Is it a difference of two squares? X plus 1, x minus 1. Very good. So the second step is factor. So first, set the denominators equal 0, solve for x. Second, factor your denominators. Third, now you find the LCD. What's the LCD?
X plus 1 and x minus 1.
X plus 1, x minus 1. And then we go on through the rest of the steps. So multiply x plus 1, x minus 1 to each term. X plus 1, x minus 1. So once I factor them all out, I know what my LCD is going to be. I multiply each term by it. Then what do you do? Reduce. Yeah. So x minus 1 cancels with x minus 1, x plus 1, x, and this one, both of them cancel. So in the first parenthesis, x plus 1 times x minus x minus 1 times 1 equals 1 times 2. All right. Get rid of multiply, get rid of parentheses. X times x is x squared. Positive, positive. X times 1 is x. Now this 1, because there's a minus sign there, I put the negative in and put the 1 there. So negative times positive is negative x. Negative and negative becomes positive. 1 times 1 is 1. like terms, so x's cancel, so we have x squared plus 1 equals 2. Subtract 1. So x squared equals 1. So those are my solutions. Can I use them? No, because earlier we said that we can't use positive negative 1. So what does this one tell you? No solutions. Because the only possible solutions we have will make the bottom equal 0, so it's no solutions. Pretty straightforward. That's rational equations. Let's finish up this section by looking at radicals now. Radical equations. First off, if A equals B, this is called the power principle. If A equals B, and if I raise A to the power n, that means I have to raise the other side to the power n. They'll still be equal. So if 2 equals 2, then 2 to the third equals 2 to the third. So let's say we have with this example, square root of 3x plus 1 equals 4. Same concept. We have an equal sign. We have to get the x by itself. So move all of the x's to one side. Check. Non-x to the other side. So how do we get rid of the square root? Square. Whenever we do one side, we have to square to both sides. So the square root and the square cancels, leaving me 3x plus 1. 4 squared is 16. Yeah, 4 times 4 means 16. Now solve for x. Subtract 1. 3x equals 15. Divide by 3. X equals 5. And again, you have to check your answers. 3 times 5 plus 1 equals 4. 15 plus 1 equals 4. 15 plus 1 is 16. Square root of 16 is 4. Check. Okay, we have square root of x minus 1 minus 4 equals 0. Are all the x's to one side? Everything else to the other side? No, there's minus 4 there. So I have to get 4 out of there. We have to basically isolate the radical. You have to isolate the radical to get rid of it. Then next step, square both sides. The square root and the square cancel. So x minus 1 equals 16. Then add 1. X equals 17. There you go, check it. 17 minus 1 minus 4 equals 0. 17 minus 1 is 16. Square root of 16 is 4. 4 minus 4 is 0. Check. So far, so good. You have to be very careful, though. What do you do here first? Minus 2 on both sides. X plus square root of x plus 1 equals negative 2. Then what? No. No. What do you have to get rid of? What are you trying to get to? You have to look at the equations. You try and get to the x. Can you get to the x? No, the square root's there. How do you get rid of the square root? Square it. But you can't, because it equals negative. Square roots can never equal something negative. This one's no solution. Because they cannot equal, square roots can never equal negative. So that could happen, but let's pretend that it's a positive 2. You want to get to the x, but we can't because there's a square root. So we have to square both sides. The square root and the square cancel. 2 squared is 4. And subtract 1, x equals 3. Then when you check it, 3 plus square root of 3 plus 1 equals 2. Square root of 4. Square root of 4 is 2. 2 equals 2. Check. How about this one? What do you got to do first?
That's root, right? 2 minus 5 is negative. That can't be a negative, right?
It's a cube root. If you remember the graph of cube roots, it can be negative, it can give you negatives. So they'd be very, very, very careful about that. So how do you get rid of the cube and the cube root? We squared them because there's an invisible 2 right there. So whatever's inside the v, that's what we raise it to. So what do we raise it to? Yeah, we raise both sides to 3. And put that negative 3 in parentheses, because that's one number, it stays together. Well, no. So the cube root and the cube cancel, so we have 2x plus 1. Negative 3 times negative 3 times negative 3 is negative 27. Subtract 1. 2x equals negative 28. Divided by 2. Negative 14. And when you check it, negative 14 times 2 is negative 28, plus 1 is negative 27. Cube root of negative 27 is negative 3. So it checks out. All right. Here's pretty we had this. What's the first thing you have to get rid of? The 6. Get rid of anything plus or minus to it first. So 6 minus 2 is 4. Nope. Is the radical by itself? Look at it. I mean, there's not much you can look at. It's at the board. Is it by itself? No. What does it have? Well, how do you get rid of the 2? How is it connected? How is this 2 connected to the radical? Yeah, it is. Has to be something there. You see a plus sign? See a minus sign? Is it divided? So it has to be what? This is multiplied.
We divide it, right?
So we divide both sides by 2. Now there's nothing around the radical. Now we can get rid of it. Only now. Square both sides. 2 squared is 4. Subtract 1. And it works. Plug it in there, it works. Now we have an equation on the right-hand side. It doesn't have to be just one number by itself. It could be an equation. Is the radical by itself? No coefficients, no anything? Yes. It's all by itself here. So we put a parenthesis around the equation and do what to both sides? Not square root. This is a square root. Square. So the square root and the square cancel. So we have 2x plus 5. On the other side, it's x minus 5 times x minus 5. Because it's squared. X times x is x squared. Positive times negative is negative. X times 5 is 5x. Positive times negative, 5 times x is 5x. Negative and negative makes it a positive. 5 times 5 is 25. Combine like terms. Negative 5 is negative 10. Okay, by now we should know how to multiply 2 binomials together. If not, then go back and practice. Since it's a quadratic equation, it has to be equal to what before we solve it? It has to be 0. So we have to move the 2x over. So we subtract 2x from both sides and subtract 5. Negative 10, negative 2 is negative 12x. Positive 25 minus 5 is positive 20. We can't factor because what times what is 20? When you add them, you get 12. Nothing. So 10 times 2. Oh. 10 times 2, 10 plus 2. What do we know about the signs? Look at the second sign. It's a plus. What does that tell you? Look at your notes. If the second sign's a plus, what does it tell you? It means it's the same sign. If the second sign is the plus, that means they're the same signs. They're the first sign. They're both minus. What times what is 20? When you add them, because the second sign is plus, when you add them, you get 12. 2 times 10. So the answers are positive 10 and 2. You guys have to review your notes. I mean, we did a lot last time. But we're not done yet. Let's check those answers. Because if we check those answers, what are you going to find out? Right. So we have two possible answers. X equals 10 and X equals 2. 2 times 10 plus 5 equals 10 minus 5. Two times 10 is 20 plus 5. 10 minus 5 is 5. Square root of 25 is 5. So that works. So 10 is an answer. X equals 10 is an answer. Check the other side. Two times 2 plus 5 equals 2 minus 5. Two times 2 is 4 plus 5. 2 minus 5 is negative 3. Square root of 9, does 3 equal negative 3? No. So X cannot equal 2. We only have one answer in this case. Again, that's why you have to check your answers. All right. That does it for section 4. We only have one more section, inequalities. We'll do that next time. All right. So I need you guys to do your homework, please.